Yes, a very good afternoon to all of you. Am I audible and visible to everyone over here? Yes, a very good afternoon, Priyanka. Nayak, yes. Yes, Sashi, good afternoon. Good afternoon to everyone over here. I hope all of you are doing well and hopefully everybody is kind of revising things on time. This Sunday, what I see, the thing is this Sunday, whatever portion we'll be covering in today's class. So that will be up to that portion only, it will be in the test. Yes, you will have exam. That date has that has been communicated to you. So don't worry about that. You'll be having examination. Okay, shall we begin the session without any further delay? I hope the general queries I have answered and I hope you people are following and I'm giving you sufficient time for writing as well. Yes? Okay, fine. Could be the case, beta. Problem 3.3 could be the case, right? There are some kind of misprints there. That's okay. So you can check that out. Okay. So without any further delay, let us start off today's topic, right? Okay. Yeah, everything fine, right? Okay, good. Now in today's class, basically what we are going to learn is there are only few things which we are going to focus on, like focus in today's lectures, And the thing is, those things may mean small, but the thing is they are definitely going to clear your concept more. Now the thing is, I wanted to know whether you people know how to remember that D block vertically or not, because as such for S block, P block, we already know those things. Hai? For D block, I would have told you how to remember that horizontally, right? And this is a periodic table which is from the IUPAC organization itself, right? Now the thing is, here, what we are going to do is, first of all, we are going to learn some of like 3 to 12 elements like vertically down. Okay. So now in this case, let us go further. So I'll be like telling you one by one, and where it is not required, it's okay, you don't write that, okay? Because I'm not going to tell you that you have to remember this, because certain things, they're already ingrained in your brain, right? Like the way, if at all I say that this particular zinc, cadmium, mercury, you already know that basically zinc, cadmium, mercury, they are all together in one group. So for that, you don't need any other mnemonic, right? So let us go for it. So if at all, I'm saying here, for the group 3, right, which is scandium, yttrium, lanthanum and actinium. Now I am again telling you that I'm not including basically the elements which are coming in the end. We have already seen, I've already told you how to remember that. Okay, remember, actually Rutherford dubbed a song behind his metro, right? So I'm not going to include that, because as such we don't know much about the chemistry of these elements which have been synthesized, they have been newly formed, right, in the laboratory. So nothing much is known. So it's good, actually. Already the elements which are there, we should be first thorough with them. Okay. So here this one is scooter, Yamaha, latest AC. So basically you are demanding, and sometimes what happens, we being kids, what will happen, we will start, being stubborn or something, and definitely in front of our parents, if we want something latest, right, we'll always be saying that we want this, right? So what you are demanding is, you are demanding the Yamaha scooter and the latest AC which is available in the market, right? So first copy down this, I have given you for group 3, right? One thing we are going to learn, and then we are going to proceed. And here itself, I'm going to write down one group. That is the reason I'm giving you a little bit of time. You note this, and then we'll proceed further. I hope I am being very clear about it. Written? Okay. Now let us go further. Now the next one, which is group 4, this one, titanium, zirconium, hafnium. So with this, it is T zara, half. Zara is Hindi word which means little, and in Telugu it is konchum. Okay. So basically you are asking someone to pour you just half cup of tea. So that's what you are written, T zara half. Okay. So please write it down, titanium, zirconium and hafnium. Hopefully this is written. Titanium, zirconium, hafnium. Yeah? Okay, good. Now, let us move further. Next is this group 5. Vanadium, niobium, tantalum. So that let us write this as very noble task. Very noble task. Okay? Very noble task. Very noble task. Or else you can also, kind of remember like this also. Just now it struck me. You can also write like this, very noble Tata. Ratan Tata, everybody knows, right? And he is a very humble man, right? A very good industrialist and a human being. So you can remember Tata. Okay. So that way also you can remember. Yeah, any way. And if at all you are having your own mnemonic for a certain way, that's absolutely fine. I'm not asking that erase that and remember this, okay? If you're having something of your own, well and good, stick to that, okay? Ultimately, at the end of the day, what is required is you should be very comfortable with writing the kind of, identifying the position of these elements, what comes under which particular element. That's what is the major concern, okay? Hopefully, people have written this. Then, next, chromium most wanted. Chromium most wanted. Chromium most wanted, right? Okay, people have written this, hopefully. Now, let us proceed further. Then you are having this MNTC ray, right? So, money takes care of recession. Now, the thing is, I think a few of you might not be knowing about this word, which is recession, right? So, basically, you can just remember, like when the economy goes down and many people lose their jobs, right? So, basically, that is a kind of, not a good scenario, okay? So, the thing is, if at all people have saved some money as an emergency fund, so that basically takes care of them and their family during that time. So, that's what money takes care of recession. Written? I hope this is written by everyone. Okay, good. Now, next. Next we are having this one, Fe, Ru and Os, right? So basically you are telling, basically you think that you observed rust phenomena or else rusting of iron, and you are telling your sir that this rusting phenomena gets enhanced even in presence of more oxygen, right? So you are telling like that. So iron rust in oxygen, sir. Okay. So OS, osmium. Remember that. Or else you can remember like this also. Iron rust. This is iron rust. Okay. Awesome. That's awesome. Actually, spelling of awesome which I've written is wrong. Why I've written like that is basically so that you remember OS, awesome, osmium from there. Otherwise, awesome is a different spelling altogether. Okay. So it could be any way. If at all you are having something else, that is also okay. Written this one. Yeah, good. Now let us move further. Now next is this cobalt, rhodium and iridium. Now you might have seen, like you or everybody knows courier, right? And few people will announce it as courier, right? So we are going to do that. Courier. Courier. So you are having all the three elements here. Courier, right? Cobalt, you are having rhodium and you are having iridium, right? So purposely we are pronouncing it wrong so that we are like identifying what are the elements which are just one below the other. Yes, written? Good. Okay. Now, next is for the next one which is there, which is nickel, palladium, platinum. Now the thing is, for this there is no specific mnemonic which you need to remember, because you already know that nickel, palladium, platinum, right? They are all catalysts, right? We already know that, you know, in hydrogenation process they act like catalyst. Now the thing is, you just pay attention on the alphabetic order, rest everything will find its own place. N and P, which comes earlier? N comes earlier in the alphabetic order. So that's the reason nickel first, right? After that, palladium, platinum, P is same. Then it will be decided by the another symbol or else another letter which is D and T. So did you get your answer? And do you need to remember any mnemonic here? You need not. Getting it? Yeah. Now, hopefully this is clear to all of you. Now, next one is copper, AgAu, right? They all are coinage metals. Here also you don't need any mnemonic, okay? So what you remember is, as you are moving from copper to gold, the value of that particular thing is increasing. That is, copper is less valuable. Then comes more costlier one is your Ag, right? And then only it comes basically your Au, which is gold, right? In the industries, copper, kind of copper will be used for making all those kind of, big vessels, or what do you say, equipments, along with something else also, right? Alloys. But silver you'll never see because it is costly, right? So basically copper cheaper, after that little bit more costly Ag, and after that you are having gold. So as you are moving down, you are having increase in its value. Copper, Ag, Au. Is it clear? So you don't need any mnemonic for this. Good? Okay. Now next, this is like everybody knows, which is zinc, cadmium, mercury. They are non-transition elements, zinc, cadmium, mercury. So that's already known. So you know you don't need anything for that. Zinc, cadmium, mercury. Or else you can remember Zindagi, Cadbury, Jesse. Jesse is like, है ना? Like, hogi, है ना? Hogi is a kind of Hindi word. That means life will be sweet like Cadbury. That's what is the meaning of it. Hogi. Okay. Zindagi, Cadbury, Jesse hogi. Or else you simply remember Zinc, Cadmium, Mercury. Yes, are we done? Okay. Hopefully people have understood. Now there was a purpose for what I have, kind of made you remember all these things, because for S, P block, D block horizontally we knew, but we didn't know about vertically. Okay, that is also important. Okay. Now the thing is, next thing which I am going to tell you is basically about the magic numbers. Okay. Now, sometimes what happens is, in the examination, the examiner may give you, okay, this is the element, identify the atomic number for that. So at that time, you won't sit for, kind of making the entire periodic table, right? Only thing which can save you there is, or else which can lighten up your work, is basically knowing about this particular magic number. Okay, so do one thing, just put the heading as magic numbers in the modern periodic table and you note it down, then I'll explain you. As such, it is a simple concept itself. Magic numbers in modern periodic table. So here it is written 1A, or else group 1. I'll change the color, I think it is not visible. Group 1. This is group 2. P block. Here P block, as such, zero group which is there, inert gases, that is also under P block, but only for magic numbers, their magic numbers are differing, right? So that's the reason we are writing P block except zero group. This is D block, only group 3 which I am talking about, which is 3B also. Except group 3, that means group 4 to 12. This zero group. So don't think that the 18th group is not part of P block. That misconception should not be there. Only thing is, these magic numbers which are there, they are different. That is the reason we have separated them. Nothing else. No other reason behind it. So please write it, then I'll explain you. And you might be getting like, kind of terrified by looking at the numbers. Don't worry, it is easy to remember if you just follow it logically. Okay? After writing, please thumbs up so that I can understand that you have written. Okay, few people have finished. Because after writing this, I'm going to explain you and then you have to do some of the works there. Okay. Okay. Now let us try to understand this. As such, it is a simple thing only. Just follow the way I am telling you and rest everything will be taken care of. Okay. Now the thing is, here what I am saying is that the magic number is originally, I'll do one thing. I'll go to the next slide so that you are able to, kind of understand the thing. Okay. So I'm going like this. That is 2, 8. Just a minute. Okay. Now here what I am going to write is 2, 8, 8, 18, 18, 32, right? This is what is the magic number when it comes to group 1. 1A I have written, right? 2, 8, 8, 1 time 2, 2 times 8, 2 times 18 and 1 time 32, right? Now, when I move for second A or group second, so what I'm doing is cutting this off, 2 which is there, okay? So what comes now? 8, 2 times 8, 18, 18, 32, right? That is the magic number for 2A or second group. That means beryllium, magnesium, that particular family. Now, when I talk about P block, so in P block, what you have to do, you cross one more, 8. And here you remember for P block, when you're crossing 8, in place of that, you are including one extra 32, right? So what you are doing is 8, 18, 18, 32, 32, right? Let us go revisit it. So what I did, I said for first A, you are having 2, 1 time 2, 2 times 8, 2 times 18, 1 time 32, right? When you go for group 2A, so what you are doing is cut that particular 2. You'll be left out with 2 time 8, 2 time 18, 1 time 32, right? Now, when you move for P block, what I said, you now further cut one more 8. But in process of doing that, what you are doing is, you are including one more 32. Are you able to see that? Hopefully, this is absolutely clear, right? Okay. Is it clear? Is there any confusion here? Able to follow, right? And when you are learning also, please remember like that only, sequentially, okay? Now, here I have not written like except noble gas I am talking about, right? Now the thing is, next comes D block. In D block also, only group 3. Now the thing is, I'll do one thing from here. Assume that we are learning for D block from deriving from the P block itself. And here also, D block, and this one is for group 4 to 12, right? Now the thing is, for this particular group, group 3, that is scandium, yttrium, lanthanum, you cut across first one, which is 8. Now what you'll be having? 18, 18, 32. Just take 3 numbers, right? Because there are 4 rows, so you just require 3 numbers. So that's what you have taken, 18, 18, 32, right? 2 times 18, 1 time 32. Now when it comes to group 4 to 12, right? So what you do, you cut across one more 18 and you'll be left out with 18, 32, 32. Do you understand? Because the D block starts with period number 4. 4, 5, 6, 7. So you need one here, one number here, one number here. So that's the reason we are choosing only 3, right? So I'll repeat once again so that you can relate to it, okay? And you remember like that only, okay? So group 1, 1 time 2, 2 times 8, 1 time 18, 2 time 18 and 1 time 32, right? When it comes to group 2, you have cut across that 2, you are having 2 times 8, 2 times 18, 1 time 32, right? When it comes to P block, you have cut even one more 8 and you are left with, and when you have cut that, you have added one more extra 32. So it is 1 time 8, 2 time 18 and 2 time 32, right? Now, from that P block itself, you think that you are deriving the magic number for D block, right? So in that case, you cut across that 1 8 also, right? And then you will be having 2 18s and 1 32, and that is only for group 3. For group 4 to 12 in D block, what you are going to do is, you cut across that 1 18 also, and you will be having 18, 32, 32. Are you getting it? As such, you have written, this is the, you have to cut it for the next one which I have told you, okay? Don't think that you don't have to write this 2 also for group 1A. Is that clear? This is only to make you understand how we are going, right? Now, last one is group 18, or else it's better you remember 0 group. And for them, 2 times 8, 2 times 18 and 2 times 32. So you remember one thing, for 0 group, as such their value is 0. But they want everything which is more 2 times. 2 times 8, 2 times 18, 2 times 32. Will you be able to remember? For 0 group, you remember their value is 0, but their demand is so much. Whichever is heavier, that means whichever is higher. That is, everything they want double, 2, 2. That means 2 times 8, 2 times 18, 2 times 32. Clear? So now hopefully you remember it, okay? If at all I remove this, so people should be comfortable with that. है ना? This is what I have written or mentioned on this particular slide, right? So you are having this 1A, group 1. So you are having 1 times 2, 2 times 8, 2 times 18, 1 times 32. For group 2A, cut across that 2. So you'll be having 2 times 8, 2 times 18, 1 times 32. For P block, again you cut across one more 8, 1 times 8, 2 times 18 and 2 times 32 because you've added one more extra 32. For D block, only group 3. So it will be 18, 18, 32. For D block itself, group 4 to 12, you'll be having 18, 32, 32, right? And for group 0, it is 8, 8. 2 times 8, 2 times 18, 2 times 32. So you remember like that. Hopefully this is clearly registered in your brain. Now let us go for, kind of seeing these things here. Now, are you able to see this is group 1A, right? In the periodic table. Atomic number here is 1. For group 1, what was the case? 2, 8, 8, 18, 18, 32. So, are you able to see? 1 plus 2, you got this lithium. 3 plus 8, you got this sodium. Then again, 11 plus 8, you got your potassium, which is 19. Then 1 times 2, 2 times 8. Again, what you have to do? Plus 18, you got 37. Then again, plus 18, you got cesium. Then plus 32. You ended up with this. So, are you able to locate all the elements here? Right? Easily. Just on the basis of this magic number, which is 2, 2 times 8, 2 times 18, and 1 times 32. Okay? Now, let us go further. Now, the thing is, you already know that in the periodic table, elements will be they are arranged according to their increasing atomic number. So, once you have written lithium, lithium atomic number is 3, then you move on to the fourth one, which is beryllium, right? Now, beryllium is 2A we are writing, right? So, for this, what is there? We are not having that 2, okay? What we are having? 8, 2 times 8, 2 times 18 and 32. So, plus 8, plus 4 plus 8. 4 plus 8 is 12. Again, 2 times 8, right? So, you got this. Then, you have to add 18. So, 20 plus 18, you will be getting this particular 38. Again, plus 18. You got this barium, which is 56. And again, 32. You got this radium. Right? Got it? So, that is the story of basically you have got this for second group. Now for P block, you again cut one more. And when you are cutting 1, 8, bring here 32 extra. And that story follows from boron to fluorine family, right? Now the thing is here, you see 5. 5 plus 8, 1 time 8 you have to add, right? That is basically 13. 13 plus 18, which is 31. 31 plus 18, which is 49. 2 times 18 done. Then go for 32. 49 plus 32 is 81. 81 plus this 32, it will be again 113. Getting it? So the same story continues from this boron to fluorine family. Okay? Got this? Is there any doubt here? Are you able to see how it is happening? Digesting the things, right? Okay. Now, when it comes to this last group, right? So what we know, their value is 0. 0 group. Demands are double. That means 2 times 8, 2 times 18, 2 times 32, right? So are you able to see? In helium, 2 is the atomic number. Add 1 time 8, you got neon. Add 1 more time 8, you got argon. So 2 time 8 is over. Then add 1 time 18, you got krypton, which is 36. Add 1 more time 18, you got 54, right? Which is xenon. Now 32 you add, you got radon, right? Then you add another 32, you got oganesson. Got it? 2 times 8, 2 times 18, 2 times 32. Okay? Good. Now, let us go for the next one, which is basically, now we are entering into the D block. In D block, there are like 2 sets. One is for group 3 and another one is for 4 to 12. Right? So, for group 4 to 12, we are having what? 18, 32, 32. for group 4 to 12. For this, we are having 18, 18, 32, right? This extra 32 here because we have already added, lanthanides and actinides which are extra over there, okay? Now you see here, scandium. You remember for group 3, it is 18, 18, 32. So if at all you are having scandium, yttrium, lanthanum, actinium. So what are you going to do? This is 21. Add 18 to this. Are you going to get 39 here, right? Again, you add 18. You are going to get 57. Again, you get 32 add here. You will be getting 89. Are you getting the answer? Now, do you understand why we are taking only 3 things from there, from that P block? Because I just have 4 rows of these D block. We have studied now that there are 4 transition series. So for 4 gaps, like 4 rows, we just want 3 numbers. So that is the reason only 3 numbers. Okay. Now, if at all you go for, suppose this. So what you are having is 18, 30 to 32. So zinc is 30. Add 18 to it. You will be getting cadmium, which is 48. Again, 32 you add, right? So it will be 80, which will be mercury. Again, 32 you add. It will be 112, which is copernicium. Hopefully, this is clear to you, everyone. What is the magic number, right? And we'll now use that magic number for identifying the atomic number. I hope this is clear to everyone. There is no issue. Okay. So let us go further. Now I'm going to give you a question, and what I want is honesty from you people. That means when I'm giving the question, please don't sit with your NCERT or any periodic table open in front of you. Otherwise, you will never know. You will never understand, right? If you have to learn this, or else if you have to understand the concept, you have to close that NCERT, right? For the time being. Getting it? After that, if you want to practice, you can open randomly, you write any element's atomic number or else any element and you see whether you have predicted it correctly. I hope I made myself very clear. Okay. Now, next one. So let us write down the question here. Question says, find the atomic number of the following elements, right? In that, what I am having is, let us say I am saying I am having gallium, I am having Sn, then let us say I am having tellurium, and I am having bromine. I am also having, suppose, oganesson. I am having yttrium, right? And suppose I am having niobium, right? Suppose I am having now calcium, right? So these are few elements which I have given you. Now what I'm going to do is, I'm going to show you one of them, and after that you are going to calculate. I'll give you some time and then I'll discuss everything over here, okay? Now let us say for Sn, right? Now what is the prime requirement for finding out the atomic number? First of all, you should be well aware about your entire periodic table. That means you should be knowing what is the first member of at least each group and what are all the members of that particular group. So you must be very clear about that. Okay, otherwise it's very difficult to do the question. Okay. And then second thing is, you must know what is the magic number for different blocks which we have learned. Because the moment block changes, this magic number is also changing. Okay. And that is because that not every block is starting with the same thing. I mean same period. Getting it? Like D block, it is starting from the 4th period. Okay. P block from the 2nd period. You are able to see that. Okay. So you first identify this tin. It is in which family? It is in which group? Yes. It is in basically carbon's family. Okay. Good. So here what we are going to write, carbon, silicon, germanium, Sn, right? And this one is basically what? P block. For P block, what is this? 8, 1 time 8, 18, 32. That's what is there. And in fact, one more 32 is there. This is the magic number for P block. So what I am going to do is, I know this is 6. 6 plus 8, 14. 14 plus 18, how much I am going to have? 32. Then 32 plus 18, did I get 50? So 50 is the atomic number of Sn. Getting it? Yes. So I'm giving you a little bit of time, right? You have the magic numbers with you. Please don't look into the periodic table. Otherwise, it's simple. You will just see which element is there and you'll say that, okay, ma'am, this is the atomic number. And you'll never really learn, right? So better be honest with yourself and then we'll discuss them, okay? At max, you can refer to the mnemonic which we have like kind of learned today, which is in a particular group how it happens for D block. That is kind of understandable. And once you are done, please do thumbs up so that I can come to know, okay, you have finished it. Yes. Good. Okay, let me see if at all you have done few of them. Now, did you identify gallium, right? So gallium means we know that Bal Ganesh in Thailand, remember? So we are having boron, aluminium, gallium. Once you identify which group, you identify the block. Block is basically P block. For P block, 8, 18, 18, 32, 32. So what we are going to do, this is 5. You add 8, that will be 13. Then you add 18. What you are going to get? You are going to get 31. So that is the atomic number of gallium. Good? Is it matching? Yes, very good. Now, when it comes to tellurium, so tellurium, remember, oh Salman Khan selling teapots, right? So, oxygen, sulfur, selenium, tellurium. Okay? Now the thing is, again P block. So it is 8. What you are going to do? Add 8 here, 16. Then 18 here. So are you able to get 34 here? Now, plus what I have to do? Again 18. So what I'll be having here? 52. So did you get tellurium as 52? 52 is the atomic number. So if at all the question comes, the atomic number of tellurium is, so will you be able to now find it out? You won't be, kind of searching for periodic table, or else you won't be writing the entire periodic table. Magic numbers will help you sort out that. Okay? Good. Now, next I have given you for bromine, right? So for bromine, it is fluorine, chlorine, bromine and iodine, right? I'm not writing the entire group the moment I'm getting my element, okay? This is group 17. Which block? P block, right? So it is 9. So just add once 8, you'll be getting 17. After that, add 18 once, that is 35. So I got this one. If at all I wanted for iodine, so what I'll do? Further add 18 to this. Clear about it? Now for oganesson, you already know that is the last element, 118. You need not even do like this, right? If you want to really do, you could have done, not an issue in that. Helium, neon, argon, krypton, xenon, radon, oganesson, right? So we could have done, this is 2. 2 plus 8, this is 10. 10 plus 8, 18. 2 times 8. And after that, 2 times 18, 36. 36 plus 18, 54. 54 plus, this is already like 18 done. You do 32. So basically it is 86. and again you do 32, you are having 118. Since we have already kind of practiced learning there or already the atomic number, that is the reason I said for organization you could have directly written. Okay. Now for yttrium, niobium and calcium. So I'll take you to the another slide. Hopefully people are done with this, because if at all I write here, everything will be again a mess. Or else let me see. Yttrium. So say it is scandium, yttrium, lanthanum. It is group 3 element, right? For group 3, what was there? 2 times 18, 1 time 32. So scandium is 21. So you must know what is the first member and its atomic number. So 21 plus what? Plus 18. Will you get 39? That's what is required. Okay? Then vanadium, niobium. Remember? Very noble Tata. Okay? So that in this you are having 23. And it is group 5 member. So group 4 to 12, that range is coming. So what you have to do? You have to go for 18, 32, 32. So basically here you just add 18. How much we are going to get? 41. Niobium is 41. And after that, if I wanted, it should be, for tantalum, it should be, I have to add 32. Able to follow everyone? Are you getting it? And were you able to find the answers yourself or not? Okay, good. For calcium, beryllium, magnesium, calcium. I identified the group which is 2A. So for 2A, what is required? 2 times 8, 2 times 18, 1 time 32. So basically, it is 4. 4 plus 8, 12. Then plus 8, 20. Did you get your answer? So understood how I need to find it out? Be it any element. Except for the F block. We are just learning for S, P and D. I hope this is clear to everyone. Yes? Able to digest how the magic numbers work? What is the magic they are doing? Right? But magic numbers, magic will seem like it a magic only if you understand the thing. Otherwise, you will feel like these are just the absurd numbers and they're not solving any purpose. Okay, can we proceed further if you are done? And hopefully every one of you could do it. If you are getting stuck up also at some place, not an issue. You have the entire periodic table with you. You just ask randomly, you write down the atomic number and then you identify yourself. I've just given few of them, right? Okay, so let us go further. So those of you who could do all of them, wonderful, very good. You are able to digest all the concepts. You are kind of paying attention. That is the reason you are able to perform here. Okay, very good. Now next is we are going for the exceptional electronic configuration here, right? So please put a heading stating exceptional electronic configuration of D block elements. So put the heading as exceptional electronic configuration of D block elements. Now here basically what I've done is I have basically this is taken from your NCERT only, D and F block elements, remember, right? So from that NCERT itself I have taken the configuration which they have mentioned for 3D, 4D, 5D and 6D series, and we are going to see that what are those elements which are having some discrepancy in their this particular electronic configuration, right? So first I'll give you the kind of I'll give you the trick for that so that you remember these are the only elements, okay, in D block. So we'll do one thing. So let us write down the following elements show deviation in their electronic configuration from rest of the members of their group. Okay. So what are those elements? So I'm writing Nawab cried more. Nawab is nothing but prince, right? So Nawab everybody knows. Nawab cried more, right? Now we'll find out what is the reason. Why did he cry? Okay. So Nawab cried more as his precious metals. Now the thing is, in earlier days for kind of prince and king, for them the precious metal used to be when they are happy they'll be just distributed in coins, gold coins, silver coins and any coins, right? So those were their precious metals. So what are those? Copper, Ag, Au, Rg and platinum. See, copper, Ag, Au and Rg, they all are in the same group, right? So remember, copper, Ag, Au to already know. Rg you treat it as rose gold. Rose gold. Hai? You might have seen certain watches now coming in that rose gold, okay? If you go for purchasing a watch, or else even nowadays in jewelries also, right? Rose gold kind of thing is there. So basically that also you can treat it as a costlier one or the precious metal, right? And one more which is there, platinum, it is more costlier than your gold also, right? So all these precious metals Nawab was carrying, okay? So hopefully you understood this. I've just written half of it, okay? So Nawab cried more as his precious metals fell into puddle. This puddle is PD. Puddle means this is a small pool filled with water, okay? Puddle, okay? Who dug this? Somebody would have made this, no? So dug by rude rhino. So rude, ruthenium, rhodium, right? So I'll tell you the entire story now. So you remember like this, that Nawab was going, right? Nawab means a prince, okay? He was carrying what? He was carrying his precious metals. What are those precious metals? Copper, Ag, Au, rose gold and platinum, you think, okay? Now what happened when he was traveling, he didn't see that there was some puddle. Puddle means a small pool of liquid, right? And who has dug that? Basically a rude rhino, hai na? Not well-behaved rhino, right? So he has dug it. And in that, all those precious metals fell. And because of that, he started crying. So how many elements you are able to see here? Are you able to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now you have to put star mark on this palladium. Put a star mark on this palladium. I'll tell you why he is the star candidate after some time. So put a star mark. Please write this, then I'll tell you how their configuration is different. And once you finish writing, let me know. Good. Yes, are we done? Can we proceed further if at all you have done writing? And on palladium, don't forget to put a star mark. Finished? So I'll write now the electronic configuration. So you can write after this point, okay? So the electronic configuration of these elements differ by 1 electron from N plus L rule The electronic configuration of these elements differ by 1 electron from N plus L rule. Then you write down except for palladium, right? For palladium, the star mark is there. For palladium, the electronic configuration, or else there is a difference of 2 electron from the N plus L rule in its electronic configuration. First you write this, you'll understand this, okay? This I have written as there is, okay? You write this is very easier to understand. You can easily verify also. Yes, written everyone. Now we'll try to understand the meaning of it. Don't worry about it. Now, I'll take you back here to basically what configuration which I have shown, and we'll try to, kind of find out those elements. So what we have written, Nawab cried more. Why? Because his precious metals, copper, Ag, Au, rose gold, platinum, right? They fell into a puddle, right? Who has dug it? Rude rhino. So did you identify all of them? Yes, you are able to see that. Okay. Now, let us try to understand what does it mean by difference of 1 electron from N plus L in their electronic configuration. Okay. So here, let us say for chromium I am writing 24. So chromium, if at all I have to write down its electronic configuration, I will be taking helium, neon, argon, krypton and xenon, right? Now, which inert gas is closest to chromium, or else before chromium? You are having 2, 10, 18, 36 and this is like 54. So you are going to take argon, right? So you write down argon. Then argon marks the ending of which period? It marks the ending of third period. So you are supposed to do the filling in 4s. This is 18, 19, 20. 20 done. Then you are going to write down 3d4, right? This is what is according to the N plus L rule you should have written, right? So I'm writing this as according to N plus L rule. But what is there in reality? But in reality, there is a difference of 1 electron from N plus L rule in their electronic configuration. That means you have to move one of the electron from this Ns to N minus 1d because half-filled subshells are more stable, right? So here you will be writing argon 4s1, 3d5 and this is what we write. Understood? Okay, that's what is the meaning. You can also check for rest of the elements. Now I am telling you for palladium. See, the thing is for palladium I can now find out what will be the atomic number. I know that nickel, palladium, platinum is there. For nickel 28 is the atomic number. Now nickel, palladium, platinum group 8 I am talking about. So it will be 18, 30 to 32. So I have to add 18 here. Once I add 18, what it will be? 46. So did I get my palladium? Palladium is 46. Now for writing the configuration for palladium, Which one is closer by? Krypton, right? So I'll be writing like this, krypton. Krypton marks the ending of 4th period. So the next electron is going into 5th period. So you are going to have, this is 36, 5s2, 4d8, right? That should be there according to N plus L rule. That should be there, right? But we have written that this is the star candidate in that exception also, which is that there is a difference of 2 electrons in the electronic configuration from N plus L rule. So what are you going to do? Transfer the electron from S to D. And how many electrons you are going to transfer? 2. Then you will be having fully filled D subshell here, right? So we are going to write, but in reality, it is going to be krypton. You are having 5s0, 4d10. Clear about this, which is what we know. Understood, everyone? So please make a note of it. And rest of the members, you can easily verify that Nawab we have written na, niobium, tantalum, right? Nawab, crying, molybdenum. For all of them, that will be like this only. All you need to do is shift 1 electron from Ns to N minus 1d. Only for palladium, 2 electrons from Ns to N minus 1d. I hope this is clear to you. Hopefully written. Then let me know. Then we'll proceed further. Okay. So for D block, it is clear, right? You're able to understand. And you can also relate. Remember, we have written the general electronic configuration for D block as N minus 1D, 1 to 10, but Ns 0 to 2. So that 0 was only case of this palladium, right? You can also see for yourself. You're able to see only for palladium here, you are having 0. Rest nowhere else you are having 4s, right? So when they have given you the configuration, here they have not mentioned which inert gas, that is understood, right? And they have given you about 4s 3d, like which shell was getting filled up. Getting it? Or else which subshell was getting filled up. So you can write for all of them, or else the exceptional one and see yourself, right? So it is like for exceptional, I've already told you, rest of them, they are just following the N plus L rule. There is no exception in that. Okay? Now, let us proceed further. So now put the heading as exceptional electronic configuration in case of lanthanides. Okay? So you should be writing exceptional electronic configuration for lanthanoids. Now, first thing first, we need to remember, you don't have to worry about this. You have to remember basically what are the elements here, right? Their symbol, okay? Now, the thing is, I'm going to divide this, or else I'm going to give you this mnemonic, but it is like in breaks, okay? Because these are kind of weird elements, so it's very difficult to form a kind of a one single statement, right? So here what I'm writing is latest century presented new dynamic PM where on social media. Now the thing is, latest century. I mean, all of the youngsters, their maximum time they're on the social media. So what they did, they presented their own elected the new dynamic prime minister on social media itself. Hai? So here what we are writing is basically, you can see the kind of words which is chosen here. Basically that will help you out in remembering the element symbol. So this is lanthanum. You are having cerium, Ce, praseodymium, right? Then you are having neodymium Nd, new dynamic. In one line only you write. Then promethium PM I have given. Then samarium SM. So please make sure you are writing this first, and then I'll be giving you the next one. I hope you people have written everyone. See, in your notebook, you are supposed to write down the name of the element, the symbol of it, and the atomic number. Okay, hopefully people have written. Can we proceed? Okay, good. Now, let us go further. So, up to samarium we have written. Now, European so here it is European government decided to ban dirty hotels, right? So the thing is, you remember something like this which I am telling you. What European government found, all those hotels which are not being used now, sometimes it is like some abandoned hotels will be there which are not at all usable. So ultimately what they thought, they should be completely banned. There should not be anything available on internet also about them. So completely banned from the European government, right? So here you see European, right? European. EU is the symbol. Government decided. So just take the first letter of it. So you'll be getting gadolinium. Okay. To ban. So are you seeing TB? Terbium. So mnemonic is like that so that you remember the element symbol. Dirty. DY. Starting and ending of it. That is dysprosium. Okay. Hotels. HO you take. Holmium. Got this? So please write this and then we'll proceed further. And once you are done, just let me know. Yes, written. Okay. Now let us go towards the next set here, which is the last one here. So basically, here you remember, engineer. Now see, doctors will be using DR in front of their name. Engineers, ER. So engineer to make. So just take first letter of it, TM. You'll be getting that, thulium. To make yellow building. Yellow building. Building is this YB. You are able to see that? Ytterbium, yellow building, luxurious. Right? LU. So the thing is, what is the story here? there is some yellow building, that means which is in very pathetic situation, right? And an engineer has been hired, and what is his task? He has to make that building grand again, luxurious again, right? So that's what er for engineer. Then to make, tm, thulium. Yellow building, yb. Just take the first letter of it, luxurious, lu, lutetium, right? Write this quickly and then we'll discuss about the configuration here. Yes, are we done writing it? Yeah, good. Okay, now I hope people have written. So let me tell you what is exactly here with what we are looking for. So after this you write down for lanthanum, cerium and gadolinium. This is 57, 58 and this is 64. So this is plus 6 here, right? And you can remember like this, lace good. See, nowadays, there are a variety of shoes which are coming. You will find that the shoes are very simple, maybe pure white. And I remember one of my cousins, she had that kind of shoes, right? So with that, I have related. So the shoe was actually very white. And in that, it had, colorful laces. Okay. So everybody's eyes will be going on that only. And you'll, rather than appreciating the shoe, you'll appreciate lace is good, right? So that's what, lace good. Okay. So lace, in that lace itself, what are the elements whose electronic configuration is exceptional, right? So here, just first letter and last letter, club it together for GB, right? So for this lanthanum, cerium, gadolinium, there is a difference of 1 electron from the N plus L rule in their electronic configuration. EC is electronic configuration. So let us see for lanthanum. For lanthanum, lanthanum is 57. Now which inert gas is closest to this? That is xenon. Xenon is 54, right? And xenon marks the ending of 5th period. So it should begin, next electron should be going in 6th period, right? And I hope you know that if we are writing, first we are filling Ns, after that it is N minus 2F, and after that it is N minus 1D, and after that we are writing NP, right? But you don't have to blindly use it. You must know from where that particular F will be there, right? Only in the 6th period and 7th period you are having 4F and 5F. Getting it? Now, xenon is 54, 5th period over, 6th it is, so 6 is 2, right? After that, where the electron should move into 4F, how many? 1 electron. And I'm writing here 5D 0, right? This configuration which you are writing, this is according to N plus L rule. But what is observed? But in reality, it is observed that there is a difference of 1 electron from N plus L rule in their electronic configuration. That means you have to make this time shift 1 electron from F to D. In the previous one in D block, what you did, shifted 1 electron from S to D. Here from F to D, right? So what you are going to write down? Xenon, 6s2, 4f0, 5d1. Right? That is the reason lanthanum is known as D. Getting it? So please write this. For gadolinium also we will see. And hopefully, if at all you have written, like if you finish writing it, you must write down on your own for gadolinium. Because previously also in the examination, in the NEET examination, it has been asked. Yes, are we done writing? Okay. Now let us go for gadolinium now. For gadolinium, it is 64, right? Now again, which inert gas is closer to it? Xenon. So 54 is done. You will be writing 6s2, right? Then you will be writing 4d. How many electrons more now? 4d8. Right? 1 minute, I think I have written it something wrong here. Gadolinium, it is basically 64. You are having helium, neon, argon, krypton and xenon, right? So for gadolinium, again, which one is closer? You are having this as xenon. Xenon marks the ending of fifth period. So after that, we'll be having 6s2, 4f8, right? This is 54, right? So 56 plus 8, 64 done. And then you will be writing 5d0. This is what? This is according to N plus L rule. Getting it? But in reality, what is there? But in reality, actual configuration is differing by 1 electron, right? That means you will be shifting 1 electron from 4f to 5d. So that what it becomes 4f7 and it will be half-filled subshell, which is more stable, right? So you're going to write down xenon 6s2, 4f7, 5d1. Getting it? And this is what is the configuration which you see. Got it? So please make a note of it. Then we can quickly move on towards the actinoids. Yes, hopefully written. Yes. Now let us move on towards last segment here, which is basically for actinoids. So put the heading as exceptional electronic configuration for actinoids. And here you see, everybody might have watched this movie, na, where Avengers and all. So there is a character named as Thor, right? So here, basically what we are going to, kind of make mnemonic with that only. So actually, Thor protected what? He protected 3 planets. What are those planets? Uranus, Neptune and Pluto, right? So write this. So Thor protected 3 planets. What were those planets? Uranus, Neptune and Pluto. Okay. Hopefully written this much. Yes. After that I am writing here itself, or else I don't have space, so let me just write this. This is American commissioner back from California. See, you remember, you form a kind of story link between these two. That means, as such, protecting those 3 planets, right? So Americans are basically researching something on that. So as such, it was the duty of American commissioner to take care of it. But what happened? He went to California, right? So when he went to California, so in place of him, who took care of those planets? Thor. Okay. Now, so after Thor has done that, he is coming back from California. Getting it? So you relate it like that. So will you, if at all you remember something like by forming a story, it will be there in your memory for longer time. Yes, hopefully written. Now for the next set, you don't require any kind of, mnemonic. See, the thing is, there are 3 scientists over here. You're able to see Einsteinium, Fermium, Mendelevium. And all of them, they are Nobel Prize recipient. Okay. So they are Nobel laureates. Now, Einstein starts from E, Fermi starts from F, Mendeleev starts from M. They're also in the alphabetic order, right? So remember, Einsteinium, Fermium, Mendelevium. And remember, I've told you for remembering the atomic number from 101 to 1118, Z greater than 100. In that case, 101, it was Mendelevium. So above that, alphabetic order, you remember, Einstein and Fermium. Okay. Fermi, so we also use it as a unit, no? Fermi, picometer, Fermi, like that. Clear? I hope this is clear to you. Okay. Now, next you write down for actinium, thorium, protactinium, uranium, neptunium, and you are having curium, right? So it's 89, 90, and again I am putting a star mark on thorium, so you understood what is star mark there. 91, 92, 93, add 3 here, you will be getting 96, right? So for these elements, there is difference of 1 electron from N plus L rule in their electronic configuration, and write down except thorium, except thorium. So first write this down. Written? So you're able to see actinium, thorium, protactinium, uranium, neptunium, and this one, curium. Are we done writing this much? Then I'll proceed towards the next one. Okay. So now let us write for thorium, there is a difference of 2 electron from N plus L rule in their electronic configuration, right? So suppose if at all I am writing for actinium, which is 89. Now, which is the inert gas which is closer to it? Radon, it is 86, and it marks the ending of 6th period. Now the next electron should go into what? 7s. So 88 electrons already done, and then you will be writing what? 5f and 6d. So 5f1 and 6d, 0. Right? So 86 and 3 you are having 89. Okay. This is according to what? According to N plus L rule. But the thing is, in reality what is seen? There is a difference of 1 from the N plus L rule in actinium. So you will be shifting 1 electron from 5f to 6d. So we are writing, but in reality, what is seen? That will be 7s2, 5f0 and 6d1. This is what is the correct electronic configuration for actinium. Okay. Now for thorium also I'll write down. For thorium what is there? For thorium again I will be writing radon 7s2, 5f2. Right? And 6d0. This is according to N plus L rule. But what is there? There is a difference of 2 electrons. Remember thorium. So, but in reality, what should be there? You are having this 7s2, 5f0, 6d2. Getting it? So this is the correct electronic configuration of it. Understood everybody? So these exceptional electronic configurations you must know. Okay? Entire now periodic table you should be able to remember. Whether horizontally, vertically, whichever way it is. I hope it is clear. So I'll just summarize it here. In case of D block, what we have seen that Nawab cried more. Okay, there were 11 elements. In that also, in case of all the elements except palladium, there is a gap or difference of only 1 electron. But when it comes to palladium, there was difference of 2 electrons, right? Now we moved through for lanthanides. In case of lanthanides, you are having lanthanum, cerium and gadolinium. There is exceptional electronic configuration, but there is only difference of 1 electron from N plus L rule. There is nothing like 2 electron difference. When we moved to actinoids, so there in that thorium which is there, thorium is having a difference of what? How many difference? Like 2 electron difference. So in this entire D and F, there are only 2 elements for which there is a difference of 2 electron from N plus L rule, and that is basically thorium and palladium, right? So I hope this is clear to all of you, right? There is no confusion, and please practice it so that you become very nice in that, because practice makes a human being perfect, right? So better do the practice and you can definitely learn it, okay? So with that positive note, I'll just end my lecture and I wish you all the best for the test, okay? So up to this, it is the syllabus in the examination, okay? So have a nice day, right? Thank you and have a nice day.